Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to go over problems 16 to 20 of the Algebra 2 Trig New York Regents exam. All right, question 16 reads, which statement regarding correlation is not true? So we have the closer the absolute value of the correlation coefficient is to 1, the closer the data conforms to a line. A correlation coefficient measures the strength of a linear relationship between two variables. A negative correlation coefficient indicates that there is a weak relationship between the two variables, and a relation for which most of the data fall close to a line is considered strong. Okay, so just to give you a visual concerning correlation and its relationship to 1, -1, and 0. Now, correlation basically means how close is the data set, how close is it to a linear pattern, okay? So let's create a number line here. So this, let's change that. This is 1, and this is 0. Now, this is the deal. The closer you are to 1, the stronger the correlation, okay? And then the closer you are to 0, the weaker the correlation is. So let's draw a number line like this. So if you're heading closer to 1, this correlation is strong. Correlation basically means it looks more and more like a linear pattern, the collection of points. And then if you're getting close to 0 is weak. Basically, your points are scattered all over the place. So there is very little correlation happening there, okay? So think about 1 as a perfect correlation. Basically, your data points just align themselves into a perfectly straight line. And then 0, you have no correlation. Your data points are just scattered all over the place. You cannot use a line to capture the pattern that the data sets are forming. When you flip to the negative side, the same pattern holds true, okay? The closer you are to, so let me just add a detail. For 1 is perfect positive. So your line, the pattern that your points form, basically fall in line with a straight line that's increasing, okay? Has a positive slope. So that's perfect positive correlation. So perfect positive for as it gets closer to 1. So when you get to 1, it's perfectly positive, okay? And then when you get to -1, you have a perfectly negative correlation, okay? So as you get closer to -1, the strength of your correlation is increasing, is getting stronger, okay? It's getting stronger to that perfect negative correlation. So we have perfect negative when it gets to -1. In that case, your data sets, the points align themselves on a perfect straight line that has a negative slope that's decreasing, okay? And then when you get closer to 0 from the left side, your correlation is weakening, okay? So this is basically a visual to help you see how correlation interplays relative to the position to 0, 1, and -1. Okay, now we can also capture this information using absolute value notation. So the absolute value of your correlation as it approaches 1, okay, absolute value here basically means it could be 1 or -1, the correlation is getting stronger, okay? And then when the absolute value of correlation is approaching 0, it's getting weaker. Okay, that's just another way to look at it. Now let's go back to the alternatives that we have. Number 1 says the closer the absolute value of the correlation coefficient is to 1, the closer the data conforms to a line. Conformity to a line just indicates a strong correlation. Closer to 1, what's the situation there? The correlation is stronger, so this is correct because you're much more you're conforming more and more to a line the closer you get to 1 or -1. Option 2, a correlation coefficient measures the strength of a linear relationship between two variables. Absolutely. And then option 3, a negative correlation indicates that there is a weak relationship between two variables. Is that the case? The answer is no. Okay, a negative correlation that is close to 0 indicates weakness, but if it's close to -1, it indicates strength. Okay, so negativity does not imply the weakness of a correlation. Option number 3 is wrong. Okay, so this is false. And then option 4, let's just look at it. It says a relation for which most of the data fall close to a line is considered strong. Definitely, remember, strong correlation means it's very much like a straight line. So option 4 is correct also. All right, let's take a look at question 17. We're computing the discrete sum from 1 to 3 of cosine n pi over 2. All right, so one thing you have to note here is that you're going to be summing 3 terms. Okay, so we're going to be looking at n equals 1, 2, and 3. Let's go ahead and compute what the 3 terms are. So what we're looking for here, we're going to be calculating A1, the first term, plus the second term, plus the third term. Okay, and this is a formula that you can use to compute what AN is. Okay, all right, so let's go ahead and carry out the calculations. We're starting with n equals 1. What is the first term? All you simply do is you take the index and you plug in it into the n of your explicit formula. Okay, so for n equals 1, we're going to have cosine of, instead of n, we have 1 pi over 2. Okay, so if you compute that, that's going to be cosine of pi over 2. You can use your calculator to compute what cosine pi over 2 is. Let me show you how to do it with the graph. So with the graph of your cosine function, we can easily compute what cosine pi over 2 is. Or you can use your unit circle. Okay, I like using the graph, so let's do that. So it takes you down here. Okay, anytime you're dealing with multiples of pi over 2, you are going to be ending up on the axis of your unit circle. Okay, so your cosine curve looks something like this. You can do this with your calculator, but I like to do it by hand because it shows you some cool mathematical relationships that happen here. So, this doesn't look good. Let's make it look better. Okay, so that's one complete period. This is 2 pi. This is pi. This is 3 pi over 2. And this is pi over 2. All right. So it's good to know how to draw a cosine curve just in case you're taking higher math courses like pre-calculus or AP calculus. All right, cosine pi over 2 right here. The maximum is 1, minimum is -1. Cosine pi over 2 is the 0 of this function, so our output is simply 0. Okay, that's the first term. Let's go ahead and compute the value of the second term. When n equals 2, what are we going to do? We're just going to plug in 2 into our n as opposed to 1 as we did for the first term. Okay, so we have 2 pi over 2. And it would simplify that. We have cosine. Oh, these two 2's divide out. So we just have cosine of pi. You can do this with your calculator, or you can use this nifty graph I drew here. Cosine of pi is -1. And then the third term, n equals 3. We're going to compute cosine of n pi becomes 3 pi over 2. So we're going to determine what the value of cosine 3 pi over 2 is. You can use your calculator or just use the graph here. We can see cosine 3 pi over 2. The output is 0. Okay, so the sum from n equals 1 to 3 of cosine n pi over 2 is simply what you get when you add up these numbers. Okay, so 0 plus -1 plus 0. Your final answer is -1. Option number 2 is our final answer. Okay, let's take a look at number 18. It says the roots of the equation 4 times the quantity x squared minus 1 equals negative 3xr. So when you determine the nature of the roots, you do not actually have to solve it when you're dealing with quadratics, okay? You can just look at use the discriminants to describe the nature of the roots. So we have 4 times x squared minus 1. We need to find the value of the discriminant, okay? The discriminant can be applied to only quadratics in standard form, okay? So it has to be, so the discriminant is b squared minus 4ac, the radicand of the quadratic formula, for ax squared plus bx plus c equals 0. This is the standard form. This equation is not in this format yet, so we have to carry out some algebraic manipulations to put it in this format, okay? Now, let's do this. We distribute 4 to these two terms, and that yields 4x squared minus 4 equals negative 3x. Now, to put it in standard form, simply add 3x to both sides, and you end up with 4x squared plus 3x minus 4 equals 0. Okay, we can reduce this, so we can just extract what a, b, and c are. A is 4, b is 3, and c is negative 4. Okay, before we start using our discriminant to describe the nature of the roots for this particular quadratic equation, let's go over what the discriminant tells us. If the discriminant b squared minus 4ac, if it is negative or less than 0, then that implies that you have imaginary roots, okay? Two imaginary roots. They're going to be distinct, okay? Or unequal. If you have b squared minus 4ac, if the discriminant is equal to 0, then what you have is a real root that is rational and equal. This is known as a double root, okay? Now, what if you have a discriminant b squared minus 4ac that is greater than 0 and a perfect square? If you have a discriminant that is positive and a perfect square, then you have real roots that are rational, okay, because you can take the square root of a perfect square, and unequal, okay, two distinct real roots. Now we have a discriminant that is positive and not a perfect square, then what do we have in this case? Similar to this, only that it's going to be irrational, okay? So you're going to have two real irrational roots that are unequal. The only time that your real roots are equal is when you have a discriminant that is equal to 0, okay? So these are the 4 cases we have: 1, 2, 3, 4. So let's see what case this problem conforms to. So we're going to compute b squared minus 4ac and determine the sign. All we care about is the sign and if it's a perfect square or not. So b is 3, so 3 squared minus 4 times 4 times c. C is what? Negative 4. Okay, let's go ahead and simplify that. So 3 squared is 9. 4 minus times minus, this is a plus, 4 to the third power is 64, and you have 73. Okay, now since the discriminant, this is a symbol for discriminant, FYI, is equal to 73, is basically bigger than 0 and not perfect, we have we have two real irrational roots that are unequal roots. This answer conforms to case number 4. Okay, discriminant that's greater than 0 and not a perfect square. 73 is not a perfect square. Okay, so you have two real irrational roots that are unequal. Our answer is, let me see, option real, irrational, unequal, option 4. All right, let's take a look at number 19. It says if f of x is equal to 2x squared minus 3x plus 4, then f of x plus 3 is equal to, so f of x, let's color code it so it's easy for you to see what's happening here. X is the input, okay? So whatever the input is, you're going to double its square, okay? Subtract triple that input, and you add 4. Okay, so this is a rule that carries out a certain operation on whatever the input is. Okay, in this problem, our input, or like the number, is an algebraic expression, x plus 3. So how do we proceed here? What I'm going to do, first of all, let me clear out my variables. So I'm going to leave this blank, and on the right side, I'm going to leave that blank. So what I did here is I took out the x's. This function is about to have an input other than x. What is the input? X plus 3, okay? So when you have f of x plus 3, you're taking this x out, all these x's out, and you're substituting x plus 3 into them. Okay, that's all you're doing. So let's go ahead and do that. We have f of x plus 3 is going to be 2 times x plus 3 square minus 3 times x plus 3. All right, let's expand this completely. Hopefully it matches one of the options we have here. 2 times x plus 3 times x plus 3. Distribute negative 3 across these two terms. You end up with negative 3x minus 9 plus 4. Okay. All right, let's simplify further. If you follow these two out, you end up with x squared first outer, 3x inner, 3x last, plus 9, minus 3x, negative 9 plus 4 is negative 5. Okay, let's do some more simplification. We have, what do we have? Let's combine the like terms in this quantity in the parentheses, x squared plus 6x plus 9 minus 3x minus 5. And then distribute 2 across all the terms in the parentheses, 2x squared plus 12x plus 18 minus 3x minus 5. And then we're going to finish this off by combining like terms. 2x squared, the second degree term, there's only one. First degree term, we have 12x, positive 12x, and negative 3x. So we combine them. Subtract, keep the sign of the bigger, plus 9x. And then we have the constants, positive 18 and negative 5, plus 18 minus 5. Subtract, keep the sign of the bigger, positive 13. That is what f of x plus 3 is. Okay, 2x squared plus 9x minus 13, plus 13. Answer is option number 3. All right, let's take a look at number 20, the last in this review installment. It says the expression x times 3i squared to the third plus 2x times I to the 12 is equivalent to. So in this problem, you need to remember your powers of I, okay? The behavior of I to the certain power, there's a cyclical pattern that exhibits itself when you carry out the expansion. Now this is the rule. I cannot have a power that's greater than 1. Okay, if you have a power of I that's greater than 1, it must be simplified. So let's use a simplification chart I'm going to create on the right here to guide our problem solving process. I to the first power is good, it's just I, okay? By definition, I to the second power is -1. I to the third power is I to the first power times I to the second power. Just multiply these two, -I. I to the fourth power is I squared times I squared, -1 times -1, which is +1. Now guess what? This cycle goes back to 1 and keeps on going. What on earth am I talking about? Well, you're going to circle back for I to the fifth power. I to the fifth power is I to the sixth power is -1. I to the seventh power is I to the eighth power is 1. You keep going, okay? So let's do it one more time. So circle back for 9. I to the ninth power is I to the 10th power is -1. I to the 11th power is -I to the 12th power is 1. So if you have a problem with high powers of I, all you just have to do is write down these 4 and just count. 1, 2, 3, 4, 5, 6, 7, 8, or use multiples of 4, okay? And then just find out where you fall in these 3, and then that's that. The quickest way to do it is you take the power divided by 4 and look for what the remainder is, okay? All right, let's take a look at this one right here and see how this chart can guide us. So we have x times 3i squared to the third plus 2xi to the 12th power. Okay, so we're going to use power of products of powers, property of exponents to simplify this. So 3 has a power of 1. What we're going to do is distribute this power to the power of 3, which is 1, and the power of I, which is 2. What does that give us? 3 to the third power times I to the sixth power plus 2xi to the 12th. Simplify this, you have 27xi to the sixth plus 2xi to the 12th. Now, what was the rule we talked about earlier? I cannot have a power that's greater than 1. If it does, you have to simplify it, okay? Now, I to the 6th, check this out. I to the 6th is the same thing as I squared, okay? Because when you divide 6 by 4, your remainder is 2. So I to the 6th is equal to I squared, which is equal to -1. So we have 27x. Instead of I to the 6th, that has to be reduced to -1. Plus 2x, I to the 12th, well, that's too big. That is bigger than 1. It must be reduced. 2 ways you can do it. Divide that by 4, okay? And you're left with 0, so that's going to be I to the 0. Anything to the 0th power is 1. Or you can use your chart right here. I to the 12th is the same thing as I to the 4th power, which is equal to 1. Okay, so we reduce that and put 1 there. And then just simplify this. This becomes -27x, -27x plus 2x. So here just subtract and keep the sign of the bigger one, -25x. Answer is option number 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. Your positive feedback is very important to us. Don't forget to subscribe for updates to the remainder of this review series. Any questions or comments, just include it in the comment section below and we'll be glad to support you. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.